Uses of mechanical energy. The uses of mechanical energy are uncountable. Although we will discuss some of the most common uses of mechanical energy. They are given below. Driving a car. The car possesses kinetic energy because of its mass and velocity. Hence it is an example of object having kinetic energy. Turning a doorknob. Turning a doorknob requires rotational kinetic energy. The rotational speed of the doorknob and its moment of inertia combines to give the rotational kinetic energy. Hammering a nail. Hammering a nail can be an example of potential energy getting converted to kinetic energy. As the hammer lowers down, the potential energy decreases and kinetic energy of the hammer increases. This kinetic energy is then transferred to the nail, which gets displaced inside the wall/wood. Breathing. Inhaling and exhaling is a result of contraction and relaxation of diaphragm. The process of inhalation and exhalation is an example of elastic potential energy. Running and walking. Running and walking are examples of kinetic energy. Aeroplane flying in the air. Aeroplane flying at a certain altitude has a potential energy. The magnitude of potential changes with the altitude of the aircraft. They both are directly proportional to each other. Riding a bicycle. Riding a bicycle is an example of kinetic energy. Greater the speed of bicycle, greater will be its kinetic energy. Top spinning on the floor. A top spinning on the floor possesses rotational kinetic energy. The moment of inertia of the top and its rotational speed will give the value of rotational kinetic energy. Suspension system used in automobiles. The suspension system used in automobiles have elastic potential energy stored in them. This energy helps the automobiles to survive bumpy roads as the suspension system acts as a shock absorber. Pendulum with to and fro motion. A swinging pendulum is an example of potential energy being converted to kinetic energy throughout its course of motion. Throwing a ball. Throwing a ball in the air is an example of energy conversion again. The ball's kinetic energy is converted to potential energy when the ball reaches its apogee, maximum height attained. And then the potential energy is converted back to kinetic energy as it comes down. Using an axe for cutting tree. The axe possesses kinetic energy which is transferred to the tree for cutting. Throwing an object from terrace of a building. This object comes under the influence of gravitational potential energy once it starts descending. The gravity keeps pulling the object down until impact. Standing in a lift. Standing in a lift is an example of gravitational potential energy. If the strings of the lift are broken, then one will experience free fall. Running a turbine. Turbine rotates as a result of kinetic energy being transferred to the turbine blades. This kinetic energy is possessed by steam/water or any working fluid used in that process. What is mechanical energy? As we discussed in above section, mechanical energy can be defined as the energy possessed by an object because of its motion or position. This type of energy is responsible for mobility of things. There are many types of mechanical energy. We shall discuss about them in later sections. Types of mechanical energy. Mechanical energy is classified broadly into three types. These types are classified on the basis of object's motion or position. Let us see the different types of mechanical energy. Potential energy? This type of energy exists when the object's position lies a certain distance above the ground. The potential energy is possessed by the object by the virtue of its height/position from the ground. That is, the potential energy is a function of object s height/position from the ground. Mathematically, kinetic energy can given as P equals mgh, where m is the mass of object, g is the acceleration due to gravity, h is the height of the object from the ground. Kinetic energy? This type of energy exists due to motion of the object. The kinetic energy is a function of mass and square of velocity. The formula for kinetic energy is discussed in the section given below, where m is the mass of object, v is the velocity of the object. Spring energy? This type of energy exists due to the position/elasticity of spring. More the string is stretched or compressed from its rest position, or will be the spring energy possessed by spring. The spring energy is directly proportional to displacement of the spring. The formula for spring energy is given below, where K is the stiffness coefficient of the material. X is the amount of displacement the material undergoes. What are the types of potential energy? Potential energy also is classified into two types. Let us see what are the types of potential energy. Gravitational potential energy. This type of potential energy exists as the virtue of object s position/height from the ground. The magnitude of the gravitational potential energy is directly proportional to the height of the object from the ground. Elastic potential energy? This type of potential energy exists as the virtue of object s condition. The condition depends on the object s material. We can say that spring energy is a type of potential energy itself. What is rotational kinetic energy? As the name suggests, the rotational kinetic energy of an object is kinetic energy possessed by an object when the object is in rotational motion. The conjugate of mass is inertia, and for linear velocity, the conjugate is rotational energy. Similar to kinetic energy, if the object has greater moment of inertia and greater rotational speed, then the magnitude of rotational kinetic energy will be more. Mathematically, the rotational kinetic energy can be given by where I is the moment of inertia of the object, omega is the rotational speed of the object. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.